Okay, thank you so much for that nice introduction. It is really great to be back in New York. Never tired of coming back to this city. I thought what I do is talk about longitudinal databases, both in medical education in general, and then also really specifically as it applies to looking at the physician-scientist workforce. As any of you all know, research never happens alone. I've been lucky to have a great research team at Washington University. Donna Jeffy is my long-standing joint PI. We have an amazing statistician epidemiologist, Yan Yan, and Jim Struthers is our data manager, which is no small task. I do want to point out, and this isn't because I'm now at the AAMC, I would be saying this anyway, all the work we've done nationally with our NIH funding really had its foundations in some very small projects we did with CGA funds from the AAMC, those little regional grants. That small amount of seed money was just absolutely critical in giving us the opportunity to acquire data and build on our work in order to be in a position to start looking at national databases. I have no conflicts of interest to report, and everything I'll show you has been IRB approved as non-human subjects research. And then, obviously, the opinions I express are mine alone, not those of any of the organizations listed or any other organizations that appear in my talk. So, this is St. Louis. Some of you may know it. This is the view looking west from the Mississippi River. That's the gateway. St. Louis is the gateway city to the west. Washington University, where I've done most of my work, is a small to medium-sized private university. We have about 110 students in each class in our medical school, and somewhere around 15 to 20% of those are MD PhD students. So you just naturally get very intrigued as to the career paths that these students pursue. I thought I'd first talk about the database, the national database we constructed, then talk about some of our work about MD PhD program graduates in particular, and then look at some of what we've learned about career paths of medical school graduates in general who go into physician scientist career paths. So, did any of you enter medical school in 93 to 2000? Okay, you're in here somewhere. So our database is constructed of individualized records of every medical school matriculant in the U.S. from 93 to 2000. And we've collected data longitudinally both from them at multiple points, if you completed the matriculating student questionnaire way back when, or the graduation questionnaire, and then various other organizations that collect individual data along the full extent of the academic and professional development of this cohort. So I mentioned we've got AAMC data from a range of sources that they collect, and we've also been able to merge that with the American Medical Association Physician Master File, as well as the National Board of Medical Examiners files and the American Board of Medical Specialties, ABMS records. And then recently we were also able to merge our entire database with records from the NIH Impact 2 database, which, if I can remember this, it's Information Management Planning, Analysis, and Coordination database, which is really the federal database of extramural research awards. So, this is my one take-home message. If you remember nothing else, I'll deliver it very early on. And that is, if any professional colleague ever invites you to go for lunch, just go. So as I mentioned, I had done some preliminary work with a CGA grant, and that involved using the funds from that to get data licensing agreements to get physician master file data, which you have to pay for. The grant was fine. We got our paper published, and a year later, the vendor, the person who'd basically sold me the data, got in touch with me and asked me if I wanted to have lunch with her that day. So, as some of you can imagine, I probably hesitated for way too long because she said, I promise I won't try and market anything. She said, I'm just literally in St. Louis. I have nobody to eat lunch with. Do you mind if I stop by? So I said, fine. And, we had a delightful lunch. And there was one of those lulls in the conversation. And I said, I've always wondered, how does the master file manage to actually pull all this data together? Because I really had absolutely no idea how they did it. And she just looked at me and she said, oh, that's easy. That's the medical education number, which I admit I'd never heard of. You can read all about it in Wikipedia. So basically, the AMA Physician Master File, and you should know you don't need to be in the AMA to be in the AMA Physician Master File. The AMA Physician Master File was started over 100 years ago. Apparently, initially, so the U.S. government could get in touch with every doctor in the country if there was an emergency. Who knows if that's true, but it probably is. And it started with little handwritten cards, and they got to type note cards, and then finally it's all been computerized. But basically, for many, many years, the AAMC has shared extensive identifying information about everyone who enters medical school with the AMA. The AMA opens a record when you matriculate, not when you graduate. And that record remains open in perpetuity. It's really designed to prevent identity theft and physician fraud and things like that. The sort of silver lining for educational outcome studies is that we've got 100% follow-up on absolutely everybody that ever entered medical school. So it's really fairly remarkable. But I never would have stumbled onto that if I hadn't actually had lunch with this lovely woman who just wanted to eat her sandwich. So that's my take home. So what this means is basically you can pull in all these different data sources and link it all across all these different organizations to learn all about one person's development, literally from the start of medical school all the way through to retirement. And actually, the AMA can tell us when somebody actually died. So it's really like the entire professional life. So a lot of you probably have heard of the Nurses' Health Study. This is really sort of considered the preeminent database for doing women's health behavior research. And something just appeared. Let's see if I can eliminate that. There we go. So if you think about the Nurses' Health Study, this was about 121,000 married female nurses. If you go back and read the original paper, they're defined as middle-aged, although they're 30 to 55. So in 1976, this was selected as the population to survey because they were thought to be reliable and educated. You know, so not bad. It was based on surveys. So basically, women were sent an invitation. If they responded to the survey, then they joined the study and have been followed up since. So these women are very regularly surveyed. Additional data is collected. I think subsets have done blood samples. I think they've mailed in hair clippings, things like that. And follow-up is ongoing, looking at things like heart disease, stroke, data from death certificates, autopsy reports. So this is really an amazing population-based sample database. It's a single owner database in that this was started by a group at Harvard. They basically own the entire database. They created it, they collect it. Its use has expanded way, way beyond the original intent, which was really to see if there was an association between oral contraceptive use and stroke or heart disease. And so it's used both by the study team and then external researchers can get access. So our medical education database is on the right. And it's similar in a lot of ways. We have 129,876 exactly medical school matriculants in it from 93 to 2000. I think this is arguably a reliable and educated population. Ours is student records based. So students didn't have to complete the matriculating student questionnaire to be in our study. If they entered medical school, they're in our study. Lots of them did complete the survey, but that wasn't necessary. So it's defined by who entered medical school. And then we've got regular survey data and data from all sorts of other places that is collected very, very regularly and updated. And as I said, we basically have 100% follow-up on everybody who entered medical school. We actually have the entire population, so we don't have to worry about whether any of our results generalize because we're looking at the entire population. And an important difference is that our database is constructed of proprietary data from multiple organizations with various time-limited data licensing agreements, data licensing freeze. So right now it's only for our use to answer our 5 or 6 research questions from NIH. So as an aside, really one of my huge interests in moving to the AAMC was to see how we could make these kinds of resources much more widely available. Some of you may know Pat Carnes at Oregon Health Sciences University. She and her colleagues wrote a paper about 10, 15 years ago in JAMA that most epidemiologic connotations really refer to the study of risk factors for disease, but really we can apply exactly the same principles to educational outcomes. And the analogy I often use, and we'll talk about this group in more detail, is sort of like thinking about the outcome of being an MD PhD program graduate. You know, it's sort of an unusual event. There's a particular set of circumstances that made that happen, and you can learn a lot about those people by comparing them to the people who that didn't happen to. So I've just summarized here to give you an idea of how we've got lots of data before medical school, lots of data during medical school, and then lots and lots of data after medical school, and we continue to follow this cohort. And then finally, just if any of you are thinking about educational research, you know, we naturally started out being curious about our own students, which was a school size of N of 1. We did our couple CGA studies. We had 6 schools. We got a little bit of a bump. But really, when you look at the difference between that and national databases, there's just no comparison. So I'm going to talk about medical school graduates. So this is some of our more recent work. And I'm going to talk about 2 different outcomes. I'm going to look at physician scientists who were NIH award recipients as one outcome, and I'm going to look at academic medicine careers as another outcome. We don't look at these 2 outcomes sort of together because historically, I think as a lot of you know, the size of the academic workforce, medicine workforce, was relatively small. And if you go back even just 25 years, something like a quarter to a third of all MDs in academic medicine had NIH funding. That's totally changed. The size of the academic medicine workforce has grown immensely. It's really just really grown. The size of NIH-funded physician workforce has definitely not grown. And the other thing we're seeing now is that there are NIH-funded scientists who aren't in academic medical centers. So if you only look at the NIH physician workforce among academic medicine, you're probably missing, we think, probably about 15 to 20% of the people actually involved in research. This was very evident in Donna Ginther's work. Some of you may be familiar with her work from a few years ago looking at NIH award receipt among applicants. And as you can see, both for PhDs and then for MDs and MD PhDs, who she considered as a single group, somewhere around a third to a quarter of the award recipients were not at medical schools. So I thought I'd now talk about some of the work we've done looking at MD PhD program graduates. I tend to think of the term physician scientist to be MDs both with and without advanced degrees. So MD PhDs are one type of physician scientist, but I don't mean MD PhD necessarily when I say physician scientist. And physician scientists can be both MDs with MD PhDs, MDs, MD MPHs. There's a whole combination. Thinking about the MSTP program that the NIH funds, the MSTP program provides funding, institutional training grants for positions. It doesn't provide funding to a particular student. So you can't necessarily say that a particular student was an MSTP-funded student because the grant goes to the school for positions, not for students. Very important to remember, not all MD PhD program graduates attended schools with MSTP-funded programs. And as we look at outcomes in association with MSTP funding in this group, I think it's important to remember that the goals of some of the non-MSTP funded programs may be a little different than MSTP funded programs that tend to have fairly specified goals due to the funding from NIH. Some of you may know this as the James Shannon Building, also known as Building 1, the Central Administration Building at the NIH. He was the director of NIH, and it was under his tenure, actually, that in 1964, I think, the MSTP program was started. And it actually started with only 3 schools, I think Albert Einstein, NYU, and Northwestern University. What happened in the ensuing 25 years is literally exponential growth in the number of MSTP funded medical schools. It went from 3 to nearly 30 in just 25 years. That growth has slowed down considerably. I think this year there's 46 maybe programs, but it tends to be somewhere around 45, 46, 47. And one of those has historically been actually a veterinary program, not an MD program. So if you have ever worked with the AAMC, you'll know that very appropriately they're extremely protective of data. You will not get identified data for any student. You will not get identified data for any school except your own. So our national database does not have individual school identifiers. However, NIH was obviously extremely interested in knowing about MSTP-funded versus non-MSTP-funded MD-PhD program outcomes. So we kind of had a lot of back and forth about this, and what we ended up doing was looking at all the public domain records, because it's public information about whether or not a school got an MSTP grant in a given year. We looked at those records over many years, and there were 129 schools to which students in our 93 to 2000 cohort could matriculate. And about a quarter of these schools, 33 of them, have long-standing MSTP-funded programs. These are the schools that have had programs for 30, 40 years. Then we could make a category of 6 programs that during that matriculation period of 93 to 2000 were just newly started. And then we had a large group, which was the all the remaining schools that have never had any MSTP funding. So this variable worked for the NIH, and it also worked for the AAMC, and so this was how we were able to look at the issue of MSTP funding. But you will note on the right that although the long-standing MSTP-funded programs account for a quarter of medical schools, they account for nearly 2/3 of MD-PhD program graduates. And then the non-MSTP-funded schools account for just about 1/3. I think most of you will know this already, but certainly the MSTP funded schools have much more gender, racial, ethnic diversity among their enrollees. They tend to enroll students who are higher performing academically, at least if we look at MCAT scores and Step 1 scores. So what we can look at in our national database is outcomes for MD versus MD PhDs, and then we can also look among the MD PhDs the outcomes of MSTP versus non-MSTP funded schools. Some of you may be familiar with Harding's publication last year, which really looked among MSTP MD PhD program graduates compared to PhD graduates, and then the AAMC publication that was released earlier this year that looks at all MD PhD program graduates nationally. So I think we've got a lot of complementary pieces looking at the same thing from different perspectives. So when we look at graduation questionnaire data about what do our graduates plan to do, we definitely see differences in association with MSTP funding, with the long-standing funded graduates, the highest proportion planning to go into full-time faculty, research scientist careers. The non-MSTP funded program graduates, higher proportions in clinical practice, higher proportions undecided. Specialty choices have certainly been an issue, and I think will continue to be something for us to focus on going forward about the impact on their careers. But certainly the long-standing schools is the one with the highest proportion that go into internal medicine. In that all other group that's next, this includes emergency medicine, OBGYN, family medicine, everything that isn't listed. And then the RAD stands for diagnostic radiology. So we see differences in association with MSTP funding and specialty. We also very importantly see differences with debt. And I think there's this misperception that MD PhD program graduates have no debt. They may not have any educational debt from medical school, but they actually do have debt. And most graduates of MSTP funded schools don't have a lot of debt, but the graduates of the non-MSTP funded schools, some of them are actually graduating with really substantial amounts of debt. So that's sort of our work among MD PhD program graduates. And now what I'd like to do is really show you our findings with our 100,000 plus graduates in terms of these outcomes. Again, we got individual award receipt data through 2014. And so for this, the awards I'll focus on are the F32 postdoctoral fellowship, the mentored K awards, the K01, K08, K23, and then predominantly the R01 awards. We have award data only right now in our database. Under Freedom of Information Act, this is public domain data. So we were able to get that. Our findings may be due to differences in application rates. They may be due to differences in award rates among applicants, or they may be due to differences in both. And we really need applicant level data to look at this more fully. I am delighted for Donna. I'm kind of sad for myself that I'm not there anymore, but our grant did get renewed, so she is getting applicant level data and will be able to do all this work to keep building on this. And as I said, our findings for R01 and RPG awards are really preliminary only. As a lot of you probably know from the NIH Physician Scientist Workforce Working Group report, the average time in that was 17 years for an MD and 13 years for an MD PhD to get to the first RPG. That's pretty staggering, but so again, my R01 findings should be considered preliminary only. The K awards, I think people who are going to get K awards have done so already. So one of the interesting things we've been looking at, as well as MD PhDs, if you look down in 2006, this turquoise is MD PhDs. And they have pretty steadily accounted for 2.5–3% of all medical school graduates. This tiny little sliver of purple is the MD Other Advanced Degree. And this is the MD MPHs, MD MBAs, MD MS. You can probably add about 10 other programs, all these other advanced degree programs. And students are participating in these programs more and more. And you can see that by the steadily increasing purple. And actually, there's now more people graduating in these MD Other Advanced Degree than MD PhD. So we think this is a group worth looking at and learning about. So we first look at just award receipt, how many people actually got these awards among all the medical school graduates. As you can see, only about a very small proportion, way under 1% of all medical school graduates get F32s, and both the MD Other Advanced Degree and MD PhDs, much higher proportion, although still pretty low proportions overall. You see huge difference for mentored K, again with the MD PhD program graduates, much higher proportion than MD Other Advanced Degree or MDs. And then R01s, again, preliminary, but still, compared to MDs, MD PhDs really hugely outperform. So I think we really do still see the great value in those programs. I'm often asked about years to award receipt. Again, these are preliminary, but certainly in our database, for each of the different kinds of awards, MD PhD graduates get there a little bit sooner than MD Other Advanced Degree or MDs, because for our database, we can actually then look at matriculation to award. People usually talk about graduation to award, but as you know, MD PhDs spend much longer in medical school. And that matriculation to award, they actually ultimately have spent longer in the whole process. The thing to remember, though, is much higher proportions of them actually get there to these outcomes. So when we looked at predictors of award receipt among all medical school graduates, again, we looked at a lot of different variables, and I'm just showing you a few, but know that we certainly controlled for graduation year, specialty choice, a lot of the other things you'd think would be important. First of all, and this has been a very consistent finding in our work, is that what students plan to do at the time of medical school graduation really, really matters. We spend lots of time talking to our students about specialty choice, and we really need to spend as much time talking to them about career planning, regardless of what specialty choice they're going into. People who had left medical school planning a clinical practice rather than a research-related career were extraordinarily unlikely to ever end up getting an NIH award. There was something about what they decided at the time they left. Among all medical school graduates, again, MD PhDs, we continue to see a substantial advantage. We see this actually for this MD Other Advanced Degree group also in F32s and K awards. And again, I don't know with longer follow-up whether we'll see that in R01s or not. And I want to spend a little bit of time talking about our findings with USMLE Step 1. So with each decile increase in USMLE Step 1 score, there was a 10% greater likelihood of F32, 20% of K, 10% of R1 award. Then when we look at F32, if you're an F32 recipient, you're much more likely to be K, and then to go onto R1. And then really, if you're a physician, you want to do research, go get a K award. I mean, you're going to be nearly 30 times as likely, considering everything else, to then ultimately get an R1. So these K awards are really hugely, hugely valuable for physicians. Looking by gender, and this has been talked a lot by other researchers as well, women were somewhere around, 43% or so of everybody, all the graduates, a little bit underrepresented, not a lot among F32 recipients, but equally represented among K awardees, and then really lower representation among R1 awardees. When we look by race ethnicity, you may notice that I don't have Native American Alaska Natives. There were literally 0 F32 or R1 award recipients who were Native American Alaska Native in our entire database so far. And I think what you can see is that compared to the proportions among all our medical school graduates, Asian graduates were slightly overrepresented among F32 awardees and less so among K and R1 awardees. And Black and Hispanic graduates were disproportionately underrepresented among all 3 types of awardees. So we've spent some time trying to figure out what's going on. Again, we're looking at pre-applicants and awardees. Donna Ginther's work, which many of you are familiar with, looks only among applicants. So again, as I showed you in the last slide, we saw positive impact in association with Step 1 score for each of the 3 awards. So we looked at models for each of these 3 outcomes with and without Step 1 in the model. And when we look without Step 1 in the model and with Step 1, the findings for women are exactly the same for F32 awards, for K awards, and also for R1 awards. So although women tend to score lower on Step 1, that's not what's impacting their underrepresentation, their lower likelihood of being R1 award recipients. We looked at Black graduates that were less likely to be F32, K, and R1 award recipients, and you'll see these findings were somewhat attenuated in each of the models when Step 1 score was added. Among Hispanic graduates, they were equally likely to be F32 award recipients, less likely to be K award recipients, and when we looked with Step 1, that difference was attenuated, no difference with R1. And then among Asian Pacific Islander graduates, they were more likely to be F32 award recipients, and that was exactly the same whether or not we're looking at Step 1 score models. So we really wanted to look at this in more detail, and so we looked at K award receipt only among the 27,521 graduates who planned research-related careers at the time of graduation, because that's, as you know from the previous slide, where most of the K award recipients were. And for this study, after some preliminary work, the difference between Asian graduates and white graduates in award receipt was entirely explained by differences in career intention. So once we only looked at people planning research-related careers, that disparity disappeared. So we combined Asian and white graduates into a non-URM group compared to the URM graduates, and you can see there was a disparity in K award receipt among these graduates planning research careers. And so we looked at mediation analysis, which is a way to really quantify the proportion of the effect of race ethnicity on the K award receipt that might be explained by particular variables called mediators. We looked at a set of 10 demographic, academic, professional development variables and tested them as possible mediators. Gender and graduation year were covariates, so we just controlled for those. And basically, in mediation analysis, we first see if there's an association between race, ethnicity, and mentored K award receipt, which there was. We then see if there's an association between race, ethnicity, and the potential mediator. We then see if there's an association between the potential mediator and mentored K award controlling for race, ethnicity. And if both of those conditions are met by the mediator, it is then tested in mediation analysis. And as I said, we had 10 different mediators. I'll just give you the very basic summary. Debt at graduation alone, among those people planning research careers, was not a significant mediator. It did not explain the disparity. When we looked at research activities, all 4 sort of research activities together as a block, so that included doing a research elective in medical school, authorship in a manuscript during medical school, F32 award receipt, and having done 1 or more years of research in graduate medical education. That explained over 80% of the entire disparity. When we looked at step 1 score alone, that explained exactly the same amount of variance, about 80% of the disparity. When we looked at all significant mediators together, so everything you see here, we also had step 2 CK in the model, specialty, MD, PhD graduation in the model, research-intensive medical school. We basically explained the entire disparity. You know, I think this probably adds to a lot of the troubling findings about what's going on with step 1 score in our medical education system. I think it's really important to point out, those of you who don't know, step 1 score is not used in the application process. You know, when you apply for a K award or an R1 award, you're not sending in your step 1 scores. You know, interestingly enough, until just the last few years, they actually did use MCAT scores, though, for F30, 31 awards. But the quality of an applicant's academic record is considered. And so we don't think this is step 1 per se, but really step 1 is a marker of all sorts of other things. As many of you know, lots of schools use step 1 in sort of determining AOA ranking, AOA eligibility, the quality of the GME program, which may relate to the research availability, quality of mentoring for residents interested in research. And all those things are considered in the Mentored K applicant review. So, as I said, we are looking at findings going from pre-applicant to award receipt. So we don't know whether graduates with lower step 1 scores are less likely to enter the applicant pool, or perhaps being discouraged from entering the applicant pool, or whether applicants with lower step 1 scores are less likely to get the awards. So hopefully within the next couple of years, we'll be able to answer that question. And I'm just going to spend a little bit of time talking about the other outcome, which is academic medicine careers. We've always been intrigued by instructors as being this sort of hidden group in academic medicine. If a lot of you read academic medicine literature, it's always promotion and attrition with assistant professor and associate. No one ever talks about the poor instructors. So we decided to look at them. And that actually nearly 40% of all medical school graduates who enter academic medicine do so as instructors. At some schools, it's as high as 90% of new appointees are instructors. And if you think about it, faculty appointees, from your day of your appointment, you're at risk for 2 different things. You could entirely leave, you could get promoted, or nothing could happen to you. So most work has tended to look at promotion compared to non-promotion, with people who left and people who stayed in the same position being combined into a single group. Or they've looked at promotion compared to people who left and people who were retained but not promoted as a single heterogeneous group. So we were able to break that up. I've talked only about data. I'm not going to talk about our qualitative work today, but absolutely I totally recognize. I don't know if Albert Einstein said this. It's kind of apocryphal that it was written on his wall in the Advanced Studies Institute at Princeton. But, absolutely not everything that can be canted counts, and not everything that counts can be counted. And I think qualitative research has a huge role to play as we look at what's going on with our medical school graduates' career paths and the physician scientist career paths. A reminder, and that's my email address. I'm happy to give you my card, and would truly, now that I'm at the AAMC, really just love to help people figure out how they can access data and do great research with the amazing resources. So I will stop there. I'd really love to answer questions and hear about your work.